Hello and welcome to this Python tutorial. Alright, so now we're going to make the push function, which will do two tasks. First, it will append a new transition or a new event in the memory. And then second, it will make sure that the memory has always 100 transitions. I'm saying 100 because we gave the example of 100 events in the previous tutorial, but in fact this will be much more than 100. This will be rather maybe 10,000 or 100,000. We'll see. But anyway, this value will be the capacity. Alright, so let's make this push function. So as usual, we start with def to define a new function. And then we give a name to this function, so we call it push. And this function will have two arguments. First, as usual, self, that refers to the object. And the next one, what do you think that will be? Well, remember, this push function will be used to append a new event in the memory. We already have the memory, so what we need now as a variable is an event. So that will be our argument, our input, and we will append this input in the memory, which is a variable of the object. Alright, so event, you can actually call it event or transition. That's the same, and you will see in the next code sections what exactly is this event, what form it has. Actually, I can tell you now, this event, this transition that we're adding to the memory, is a tuple of 4 elements. The first one is the last state, that is st. The second one is the new state, that is st plus 1. The third one is the last action, that is at, the action that was displayed. And the fourth one is the last reward obtained, that is rt. So that's exactly the form that this event will have. Alright, and that's all. We just need the event because we just want to append the event to the memory, and then making sure that the memory has capacity elements. Alright, so now let's go inside the function. So the first thing we'll do is append the new event to the memory, and that's very simple because we're going to use the append function, so that will be direct. And when we use the append function, we must start with the list to which we want to append something. And this list is of course memory. So we start with memory, and since memory is a variable of the object, we start here with self.memory. There we go. So self.memory, and then we add a dot, and then the append function, which is the first one. So append, and inside the append function, we input what we want to append to memory, which is of course our event. So event here. And that will append the new event, composed of the last state, new state, last action, and last reward, to the memory. Alright, so that's the first thing done. And then the second thing we need to do is make sure that the memory always contains capacity elements. So let's say capacity is now 100,000. That's probably the capacity we'll choose because then 1 million elements might make the training slow. So let's say 100,000. Now we're going to make sure that our memory always contains 100,000 transitions, 100,000 events, and never more. So of course, at the beginning, it will have 1, then 2, and 3. But then once it reaches 100,000 events, well, it will always have 100,000 events. So to make sure of it, we simply need to make an if condition with this upper bound that we don't want to go over. So if, okay, so the idea that we'll use here is that if we go over the limit, well, we will delete the first transition, the first event of the memory, and therefore we're going to take the len function to take the length of the memory, that is the number of elements in the memory. So here in the len function we input self.memory, that's the memory. So if the number of elements in self.memory is larger than the capacity, well, in that case, we will remove the first element to make sure that the memory always has the same number of capacity elements. And to delete the first element, there is nothing more simple. We're going to use another function, which is the del Python trick. So del, and therefore we want to remove the first transition, which is the oldest transition in the memory, because the last transitions are the ones that we append, and therefore that's the newest transitions. So the first transitions are the oldest one. And so here we want to delete self.memory and bracket, and we take the first element of the memory, which has index 0. So self.memory 0. Now, interesting, I have a little warning. which says that there is an undefined name capacity. That's because the capacity here is not the input. That must be the capacity variable attached to the object. And therefore here we need to add a self.capacity. And now the warning is gone. So now you understand even more the use of self. That's really to refer to the object, to take the capacity of the object that will be created, that is, an instance of the replay memory class. Alright, so we're done with this push function, and so now we can move on to the next function, which is the sample function, which will take some random samples from this memory of the last capacity elements. And doing this will improve a lot the deep Q-learning process. Alright, so let's do this in the next tutorial, and until then, enjoy AI!